Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on trigonometric equations. So by the end of this, I want you to be able to come up with one solution to a trigonometric equation. So, of course, a trigonometric equation has like cos thetas or sine thetas or tan thetas in it. And the basic principle is we solve this like a linear equation. We undo everything that's been done to the variable, in this case it's going to be theta, and we want to get theta by itself. Now, both of these equations here actually have infinitely many solutions. In this video, we're just going to come up with one solution that we get from our calculator, and in subsequent videos we'll look at how to find other solutions. So let's look at this one here. So what we're going to do is we're going to undo everything that's been done to theta in order to get it by itself. So this cos theta, this will be the last thing I undo. I'm going to undo everything else first in the opposite order to BODMAS. So think of it, if this was just x minus 1 over 2, we would first times each side by 2 in order to get rid of the fraction. So if I times the left-hand side by 2, I just get cos theta minus 1. On the right-hand side, I just get minus 0.1 times 2. So now I've got to undo subtracting 1 by adding 1 to each side, just like you've done a million times. So then I get cos theta equals, so minus 0.2 plus 1 is 0.8. So now, as I said, the last thing I'm going to undo is this cos. So hopefully you realize the way I do that is by taking the cos inverse of each side. We're actually finding theta an angle, if you like. So if I take the cos inverse of the left-hand side, that will just leave me with the angle theta. So of course, whatever I do to one side of the equation, I have to do to the other. So the solution here is theta equals the cos inverse of 0.8. So to two decimal places, that's about 36.87 degrees. So obviously that's the answer I would give in degrees. If I wanted to give the answer in radians, all I need to do is times this by pi over 180. So if I times 36.87 by pi over 180, I get about 0.64 once again to two decimal places, and that's if the answer's in radians. So make sure you read the question. Is it asking you to give your answer in degrees or in radians? All right, let's go on to this equation over here. So this one might look a bit more tricky because it doesn't just have one trigonometric function, it's got a sine and a cos. But when you have that, we can be really clever and turn this into something that has only one trigonometric function. So I'm actually going to do this one by dividing each side by cos theta, okay? So that isn't getting me any closer to getting theta by itself. I'm not undoing something that's been done to theta. The reason I'm doing that here is because I have two trigonometric ratios and I want to turn it into one trigonometric ratio so I can solve it like I solved this one. So how does dividing by cos theta achieve that? Well, remember, sine theta divided by cos theta is tan theta. So the left-hand side just becomes root 3 tan theta. And on the right-hand side, cos theta divided by cos theta is just 1. So now I have an equation that has just one trigonometric ratio, and I'm going to solve it exactly the same way I solved the previous equation. So I'm going to undo what's been done to theta. I'm going to undo the tan last. So tan theta has been times by root 3. So what I'm going to do is divide each side by root 3. So then I'm going to be left with tan theta equals 1 on root 3. Now, hopefully you don't actually need a calculator for this because we know our exact values. Tan inverse of 1 on root 3 is just 30 degrees or pi on 6 radians. So once again, which of the answers you give is depending on whether the question asks for degrees or radians, okay? So again, we're just treating these trigonometric equations like linear equations. We undo everything that's been done to the variable, and the last thing we undo is the sine, cos, or tan by using sine inverse, cos inverse, or tan inverse. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.